7 o'clock. Okay. So, hello all of you. I'm Ashish Vasu from IIT Kanpur. And this is Week 4's live session for Computational Programming and Week Transfer. So, I am waiting for introduction in the live session. Let's wait for 5 minutes or 2 minutes at least. Today I am going to take a class about MATLAB, how to solve formula difference, backward difference, and percentage difference with the use of MATLAB, so that we can further proceed with the coding assignment, and some basics about how to approach a CFD problem, in which we will get in the later session. Means for the later assignments, you need to approach the CFD problem also after approaching it via MATLAB. So yes, you need to do it with CFD for the CFD problem. So for that, I will cover some CFD basics in which how to tackle a problem basically, and then in the later weeks I will cover about like how to solve 2D equations, and so some basics about the 1D diffusion equation, how to solve it in MATLAB, and then in the next week I will cover about that 1D equation plus 2D equation code with codes, how to do it with MATLAB in MATLAB code. And yeah, this week this will be enough for the next assignments to approach that MATLAB problem actually. So that will be fine. Till then anybody wants to ask a question, ask. So let me start. So first I explained about the governing equations in the previous sessions, which is just a repetition for 10 minutes. So there are three basic governing equations in CFD. One is mass, one is momentum, and one is energy equation. And in momentum, obviously there are three types of momentum conservation equation. And these equations are basically called as conservation equations because that shows some type of conservation, and means mass conservation. Mass cannot be created, cannot be destroyed, and momentum conservation and energy conservation. So yeah, and we also got to know that we are applying a physical to MA into the momentum equation to the system. We can apply to the system. But for fluid, we have this control volume, and we need to apply that to control volume. Control volume. Okay. So, hello. You need to mute your. Yeah. Thanks. So we need to apply loss transport theorem, which I already explained. So yeah, let's start with differences, forward difference, and so yeah, like okay. I'm opening my reference document here, and here it is. I'm like, so in this, so now, like, I have to open. So all of you are okay and finding your course well and equations. Right? Any questions? You are yeah. What you got from reply? What you got from the reply? Okay. 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 So I think you will get reply soon. Actually, my health condition was not nice. It was not good from last 1 week. So I was not active in that. So I don't know what you got. But yeah, I know that you got some this reply that they will for elaboration. After that, what is the progress? I will. Uh, like they will inform you. Okay. In that sense. Right, today not. Today I will not explain Thomas algorithm. In the next week, maybe it will come. Yeah, but I will cover that in the next week, because today I decided there are persons who ask me doubt about basic difference method and how to apply it to MATLAB. So that I need to explain to you. Yeah, yeah. Today I'm going to code a bit to show you guys. So it's just basics today I will tell you. And the next week I think I will cover 1D, 2D diffusion equation. Along with that, I will try to cover TDMA. Thomas algorithm, I think. I haven't planned it, but yeah, if you want, I will cover that. Others also, you had some doubts in the discussion forum. Is it done? Good evening. Doubts are clear. I even don't know what is assignment for. I have to look. Is it coding assignment? Is it coding assignment? Should I look into it? Okay, let me start this. You can ask me question and reply. So yeah, so I have explained some basics before you guys came. It was just previous sessions from the previous session. You guys don't remember. So I have a I have a function fx no oh sorry fx, and this is the function, okay, and I have some value of this function at x naught. I have value fx naught, so this will be this value. Now I want to know, so yeah, question will be done by using the code. We have to solve the question by ADI method. Coding problem only solved. So yeah, so from this, whatever I am explaining this time, you will get something. I am very sure. So listen carefully today. Week 4 is Thomas algorithm. Can you write one? Can you do one thing? Write the last date of submission of week 4 assignment. 24th. Before that, my session is there or not? I don't think so. Okay, what I will do, I haven't uploaded the last week's lecture. So in that, I will try to cover that Thomas algorithm. Maybe by tomorrow I will upload that. For sure. Now I am fine health-wise. I will do it for you guys. Okay. But today listen carefully about it, about whatever I am explaining. So this is a function, and at x naught, at any value of x naught, we are getting the value of function as fx naught. Okay, and we want to know the value of this function at x naught plus h. Some infinitesimal distance h we moved, and we want to know the value of that function. So what will be the value of that function is fx naught plus h. This is just basic, yeah, you can say geometry. Okay, if we just think in the first order sense, but if fx naught plus h is equal to fx naught, if we are writing this, then This is called a zeroth order approximation. Means what does this signify? Is this fx is constant. We are assuming this as a constant, or there is a very little difference between these two terms. That is why we are considering it as a constant. But in reality, it is not like that. So we have to do what is the reality, or you can say close to reality is more than that is fx naught, which I just explained, fx naught plus L. So this is L, fx naught plus L. And what would be this L is if suppose f dash x is the derivative of this function. So derivative f dash x is what? L by, if the distance is h, so L by h is the derivative means slope is L by h tan theta, and which is f dash h, L by h. So what will be the value of L from here? Let's put it. So basically I am explaining about the Taylor series, then finite difference, then how to apply that into MATLAB. So yeah, listen carefully. H into f dash x, and you have any question you can ask in between, because I don't have to go again to the starting to explain that. So you can ask in between if you are facing any problem. So what will be this? This is first order. I will give you these notes I prepared for you guys. Approximation. Okay, and the same thing continues, and we will arrive at fx naught plus h as fx naught plus h f dash x plus h square by 2 factorial f double dash x, which is the second order approximation. Similarly, we can go, okay, and if we just continue these kind of orders, or you can say increasing the power and derivatives for more accuracy, it will come to a point in which it will go to infinity, and at the end what will be there? H to the power n factorial f n x. So this is suppose equation number 1. I have marked down equation number 1. I have marked down. Now comes how to calculate that f dash x naught. F dash कैसे? How to calculate f dash x? Okay. So f dash x naught is equal to f x naught plus h, means this we want to continue calculate. Then what I will do? F x naught minus h minus f x naught by h. Okay, h will be in the denominator, minus h square by 2 factorial f double dash x naught, and it continues. This is one part and this is another. Okay, so this is the first derivative approximation, first order approximation by forward difference method. So when we will call forward difference, when we are calculating by, suppose this is the ith point, and this is I plus 1th point. So if I am calculating by this ith points value by I plus 1th points value, then it is called forward difference method. And if I am calculating I minus 1th points from the I minus 1th points value, then it is called backward difference method. Okay, so now let's go for backward difference method. Yeah, order of, so this is order of, oh sorry, h is divided, so order of h. Till this point I think everybody knows this is basic Taylor series expansion. Do you have any questions? I don't have any questions. Now comes x naught. This is x naught minus h, as I already explained. We are going for backward difference method. So what will be x naught minus h is equal to fx naught minus h f dash x naught. Similar way, suppose my function is going in a downward direction, so this fx minus h into fx dash f dash x naught plus h square by 2 factorial f double dash x naught minus s to the power of n factorial f n x naught. Or what one simply can do is in the forward difference method, replace h by minus h. You will directly get the backward difference methods formula. So yeah, that's another way. So now let's calculate f dash x naught's value is f x naught minus h minus f x naught by h minus plus h by 2 total f double dash x naught. So this is order of h, and this is backward difference method. I hope this is clear to everyone. It is backward difference, forward difference method. You will get to know why I am explaining it in a short time. Let's go for okay, so this is equation number 2. I have given you the name. Equation number 2. Okay, and we know equation number 1, we know equation number 2. Now let's add this 1 plus 2, which is fx naught plus h plus fx naught minus h equal to 2 fx naught. So fx naught plus h is this, equation number 1. Fx naught minus h is this, equation number 2. I am adding these two equations, fx naught plus h square f double dash x naught plus h to the power 4 factorial function into the power 4th function fx naught, and 1 minus 2, what will be that? Fx naught minus h minus fx plus h minus fx naught minus h is equal to 2 f dash x naught into h plus 2 h cube by 3 factorial f triple dash x naught. So I need to calculate this f dash x naught equal to f x naught plus h minus f x naught minus h by 2h plus minus h square by 3 factorial f triple dash x naught. So this is order of h square. So this order matters, in which order we are getting, we are like neglecting that truncation error. We are truncating the function. So yeah, this is so this is a center difference scheme. The point we want to clear about order of error. This order of error, and in forward difference method, is suppose point 1 is the my h is I have selected as point 1, means I have a rod, I have divided in 10 meter rod, and I have divided into 100 parts of point 1 each, and this point 1 is h, the step of that rod. Okay, so if that is the case, then what will be my error? If I am using FDM and forward difference method, it will be 0.1. Backward difference method will be the same, 0.1. But if I use center difference method like this, in which the order of error or order of neglection is h square, then what will be this? H square is 0.01. So this error actually reduces a lot. So this is the main point of doing this exercise. You guys are not active or what? You are not asking anything. You can ask questions. Giving you 2 minutes. Other than this also you can ask questions. Not active? There are very less active students. I don't know what happened. Last week I was not well. Have anybody who have any doubt? Okay, let's take an example. This we are going to do with MATLAB also, same example. So listen carefully about this example. This is a polynomial function. Okay, so can we solve this by hand? Yes, we can solve it, and we want to know the value of derivative at x is equal to 0. What will be the value? So how will you do it? Is f dash x we will find accurate value we need to get. So f dash x will be 6x plus 5. Okay, and if we apply x is equal to 0, f dash 0, what will be the value? Value will be 5. Okay, but suppose we don't know the direct method, we want to do it through finite difference or finite difference method or a forward difference or backward difference method, any method. Let's take forward difference method. Okay, forward difference. What will happen if we have selected h is equal to 0.2? H, we know the difference between the points is 0.2. Then what will be the f dash x f0 is x plus h minus fx by h. Okay, so f0 plus 0.2 minus f0 by h is 0.2. Anybody can calculate f0, f at 0.2, f at 0.2, f at 0.2 will be, you just need to put here x is equal to 0.2. So what will be the value? Okay, let me directly tell you the answer is 5.6. The total value is the answer. You can directly put this 0.2 here in this equation and calculate this. f0 you can put, it will be 7, and divided by h into 0.2, which is 5.6. How much far is it is from the actual value is 0.6. Okay, let's do the same problem by backward difference method. Thank you, dear sir. Backward difference method. So backward difference method, what will we do is f dash 0 is fx plus h, sorry, fx minus fx minus h by h, and the value of h is same, so f0 minus f0 minus 0.2 divided by 0.2. So what will be the value here is 7.612 divided by 0.2 is 4.4. So this 4.4 value is how much far from the actual value? 5 is minus 0.6 difference. Okay. Let's do it by central difference method. There is a third method which we derive the formula for. So central difference method is f0 plus or x plus point h minus fx minus h by 2h. Okay, so yeah, f0 plus 0.2 f0 minus 0.2 divided by 2 into 0.2. Okay, so what will happen is 8.12 minus 6.12 divided by 0.4. But what's the value is 5. So when we are calculating the derivatives value by central difference, the difference is 5 minus 5 is equal to 0. There is no difference. It's a coincidence basically. But yeah, there is no difference between. So the closest value is given by central difference. That is why it is the most accurate method in all these three, because the difference in the actually the error is very less as compared the order of h square, as I already told. Okay, you can I'll give you these notes, you can calculate it by your own. Okay, let me directly come to the coding part. You will understand a bit. Okay, all of you know about MATLAB now. So let me open my MATLAB account. save it. So this is the .m file I have saved. Okay, and now I am going to write a script in which I will solve these three type of equations. Okay. So anybody in the starting facing some problem in the MATLAB? Have you tried from the day I explained some of the basic commands and something you have tried? Just let me know. Guys, you tried assignment in MATLAB. So is there any problem you are facing with MATLAB? Has also tried. So you guys faced any problem? You don't have faced any problem in MATLAB. That's very good. Yeah. Practice is needed for sure, but yeah, if you don't face any problem, then it's very good sign. Again, very fast. Others are only some persons are responding. Okay. So first thing is in every let me explain about some functions. Is one is called as polynomial function. Okay, poly I have defined something as poly r. So what will happen is so 4, 5, 7 suppose I have defined. Okay, sorry. I haven't cleared it, the previous thing. So let me clear. No, I didn't try. Okay, sorry. Anything I can write here, and because my function definition was actually a bit wrong, that's why I was getting it. Okay, that's right. And this I have defined a polynomial with 4, 5, and 6 as arguments. Means it will be what? It is 4x square plus 5x plus 6. This kind of argument is this, okay? Or this kind of polynomial I have defined like this. And another is polyder. Polyder is the derivative of that polynomial, okay? And polyvel. So these three we will these two basically, polyder and polyvel. Polyvel will give you the value of that function at that particular value. Okay. So let me explain here. The first thing we will do is clear all, close all. So this in most of the script everyone should do, and CLC. So clear all will clear all the defined name and everything. Close all will close all the other functions open, and then CLC will clean the screen. Okay, and then there is a function in MATLAB by clicking two times percentage, one time percentage you will click, then it will be um, a comment. Okay, so this doesn't have any effect in the code, but if you click two times percentage, then it's a section, and section means you can run it by section. So in MATLAB there is a facility you can run your code section by section, so it doesn't have the effect of this section on the previous or afterwards any so let me try to give this example by simply for section, how to do it in section wise manner. So suppose you need to define x is equal to 4 plus 5. Okay, and you need to print x, and this section ends here. Okay, and you just need to run this section and find the value of x. So I will just go click run this section, and this will give me this section this excess value only. So this will not clear, close anything, but just run this section, nothing else. So if we have section 2, and here we have wrote about x is equal to 6 plus 56. Okay, and okay, now I will run this section only, then this will give me the excess value as 62. This doesn't have effect on the previous section. Okay, I hope everyone understood it. Okay, so this section part is over. Okay, so let me define definition of a polynomial. Definition of a polynomial I am defining here. And what's the definition of my polynomial is poly underscore p is equal to, suppose I have given a name poly underscore p is equal to, and my what was my polynomial is 3x square plus 5x plus 7. So this is one section I have defined, and only through coefficient in MATLAB you need to define it. So what we have done in the starting, we have just differentiated theoretically in the theoretically we can differentiate, and we can differentiate theoretically in the MATLAB itself. So how we will do it? So let me start another section in the starting. So let's write what we are doing: differentiation and p. Suppose I have given a name p underscore derivative, but now comes the function that's very important, which is polydev, which is the derivative of a polynomial. We can write inside the poly p name. Poly p is the name of the name of the function we have defined. So it's done, and then we need to find the value of that function at x is equal to 0. So p underscore derivative at x is equal to 0. So we are evaluating it as x equal to 0. What to write? Polyval. So these two functions are very important, polyval and polydev. Polydel will give you, let me write it. I will provide you this code. So polydel is basically to find the derivative of the function. Polynomial function basically. And polyvel is in discourse derivative comma 0. This will be our pattern. So let's see what we were getting, and I have saved it. Now I will run this section first, so it will clear everything. Now I have this poly p. I will run this section. So I have poly p here in this, and the function is defined. Now I will run the third section, and so we now get the fx naught is 5 basically, which we already calculated in the in our copy. Okay, is it fine with everybody till now? Any problem? Okay, so these two functions are important, and now let's go towards further forward difference method basically. Forward difference method, what are the things we need to think, like we need to define is so let's first generate a section for forward method. Okay, so x naught is equal to 0. I have defined h is equal to h I have to define is 0.2 as I have defined in the copy. Okay, both the things are defined. Okay, now comes so derivative. Now we need to calculate the derivative for differentiation, but for the first approximation of derivation, and all the three will calculate the first approximation. So here how will you calculate is we need to calculate this polyval only, polyval at different points, like it is the value of f at x plus h minus value of f at fx by h. So that is what we are calculating is, so I am writing poly underscore p at x0, which is 0, plus h. So this is the f x plus h, okay, minus again polyval is the value of the polynomial at, so poly p, the value for which you are calculating, comma fx0. So fx0 is fx0. Okay, I have defined it, divide by h. So this is fine with everyone. Okay, so now I am saving it and I will run this section. What value I am getting is derivative for differentiation forward, sorry, this one first, forward. So yeah, for forward difference and again running. So Derivative for forward difference is 5.6 as we have calculated by our pen and paper. Okay. Now comes the second part, which is backward difference method. Again, I am creating a section in which again so there also we need x naught is equal to 0. This value we need. Okay, h is equal to 0.2, the same approximation we have taken, but this derivative is for backward difference. So what will be the value backward difference method in this polyval? So poly p is the value of my for which I am calculating. Then comes x naught. So f x naught minus f x naught minus h. So that is, so let's come here. I think missing anything. Okay. Okay, I think some mistake. Yeah, no, it's fine. Polyval at poly p comma f x naught minus h and divide by h. Am I right? Now run this section. So now comes 4.4 as we have calculated already. So these three are, I think, very clear. Now comes the center difference part. But before that, I need to ask you guys that are you guys getting it? Jay sir, I said that he's getting. Others? Nithya, Preeti, Shekde, Sunatha. Are you guys getting it? How to do it in MATLAB? How to approach? You have not tried MATLAB yet, but right now I am telling you now in front of. So in this, are you getting it? You can just copy paste this code and start like practicing it. What I want is I need to, like, you guys should be familiar with writing at least initial codes so that you can do it in assignments. No, don't go there. So it's 5 into 5 matrix. You can directly do it. What's the problem? 5 into 5 matrix. Let me write it. Okay, this is my command window. I will just the CSV 5 into 5 matrix you want to define. Suppose I have defined the 5 into 5 matrix you want to define as 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. Anything I am defining, so there is no particular 2, 5, 6, 4, 1, 4, 3, 4, 9, So right. Okay. This is my 5 into 5 matrix. So suppose I want to multiply A multiplied by A. It's very simple here. It's got multiplied. It's a matrix multiplication basically. Have you got it? Matrix multiplication, you got it? Yeah. So yeah, if you want to multiply element by element is so then you just need to put a point star A again, and this element by element it will multiply it. So element by element means 1 will be multiplied by 1, 2 will be multiplied by 2. So same elements will be multiplied. So there are two types of multiplication: star and dot star. Okay. So this is yeah, very useful feature of MATLAB. So you can multiply element by element and you can multiply matrices. So both are there in MATLAB. You just need to put a dot if you want to multiply element by element. Others? Let me go to center difference then, and you guys take care that you are taking, like, you are getting this, because this is, if you are getting this, then this will make your basics for CFD problems. I will try for difference methods. Yeah, I will provide this code, and this video will be provided. You can practice. It's very easy, easiest MATLAB thing. So you can directly go for MATLAB and just clicking some number and multiply that matrix like this. So let me write for central difference. Another section I am creating okay. I get that x naught is 0 actually. Manual is there. Which type of solve example? You can find it online. I don't have anything. It's not that tough. You need to start it. You just follow whatever I am writing here. You just copy paste it in your. This is called as script. So you write your script, then click on run, or click on the run my section. That it's very easy. Don't afraid. You write, and next time you can ask me. Manual, I don't know. Manual, you can search in MATLAB. MATLAB manual is there, but I don't know examples are there. Manual, so you can just type man and it will come. Derivative of central. So what people write is polyval of x naught poly of x naught minus h plus x naught minus x naught plus h, kind of that. Okay. So this is x naught plus h and minus polygon of x naught minus h divided by 2 into h. This is our center difference formula, which I have just converted into MATLAB formula. And let's run this section and see what's the value scale. Oh, we are getting 5. So there, like in the center difference, we are getting 5. So let me run whole section together. All the section I have run. So our derivative evaluated is, which directive we have evaluated is coming as 5. Derivative for forward difference is coming as 5.6. Derivative of backward difference is coming as 4.4. And center difference is coming as 5. Now let's reduce this h in each section. H reduce means increase the meshing. Increase the meshing. So 0.2 to 0.1 I have converted. Okay, here also I need to define h. Okay. So let's see what's the difference coming. So p derivative evaluated is now coming as it should come 5. Derivative for forward difference is coming from 5.6 to 5.3. It reduced. It come nearby to the value of 5. P derivative for backward difference was 4.6 previously. Now it came to 4.7, which is also nearby to 5. And derivative of center difference is constant. It's 5 because it should be. Now let's reduce this h to 10 times. Okay. Let's see what will happen. Now I have run. I run this, and see the forward difference is coming 5.03, which is very near to 5. 4.97 again very near to 5. Okay. As you start reducing it in the iterative manner, it will come down. The value will come down, and you will achieve the value of actual value of that difference. So now you got the difference between forward, backward and central difference in MATLAB, how to solve it. Okay. You guys should participate. Should I again explain that MATLAB part? I will wait for 2-3 minutes. You guys should absorb. Understood? Okay. Good. So yeah, I'm sharing this code. You guys can see and ask me any part, like any doubt in any of the part here. Okay. My screen is looking black maybe, and your MATLAB screen will not look like this. So it's just a change in color, nothing else. Okay, it's same MATLAB. So for some of the persons it will be an issue. That's why I'm saying. So okay, you see for 5 minutes. Let's take a break for 5 minutes. I'm coming. What you are writing? Nothing heard. Is there any problem? Because I was not speaking. I said 5 minutes break. So did you try? Like, did you any of you tried this? Any of you tried this? Nobody? Okay, fine. So what I will do is I will stop presenting this. Yeah, sure. I was asking about this right now. Have you tried? You can directly just copy into MATLAB, and I gave you some time. Any of you try? Nobody? It's fine. I will stop presenting. I will share that code. You try and then let me know. Okay? And now what I will do is I will share the journal idea about CFD problem. Journal idea about the CFD problem, how to approach it, and how to solve. Because from the next time, I think your assignments are put into this direction. So yeah, we want to know about the back end of the CFD. What is happening behind that? So so as I already explained about the governing equations, which are the conservation equation of mass, momentum, and energy equation. Which energy equation is the uh, heat transfer equation, and how we can uh, have that law for transfer system to fluid medium, which is F is equal to ma applied to fluid uh, control volume. I hope everybody remember that Morse transport theorem, which I explained in the first class, and why we use it. Morse transport theorem is used to convert the system to or Lagrangian equation to Eulerian equations, and there are two types of governing equations. So two aspects of the governing equation. One is mathematical aspect and one is numerical aspect. So mathematical aspect is this. So this is the so incompressible equations right now I am taking care of, in which rho or density is constant. And here, if you see, these are the mass, momentum, and energy equations. This is called as Navier-Stokes equation. And so let's come to any transport equation. All the equations are transport equations, and if we replace this, if you want to write this into the general form, this is called as transport equation. Transport of anything, transport of mass, transport of momentum, anything will come into the transport equation, under the hood of transport equation. And any transport equation, if we take the steady state part and make it zero, the transient part we will make it zero, and source term we will make zero, then these two parts will be left, and we will take these two parts, then it will come as this is called as advection. Advection is the term which is used to, like, if something is taking away something from that. And diffusion is like, so let me share some example. So if I am doing this over this, so the air coming from my mouth is taking away the heat from this pencil, and this is due to the advection. Okay. But it is, suppose I burn this and instantly the temperature start rising in the whole pencil. This is diffusion. And diffusion is one more example is if I uh, just burn anything here and smell is there in all the room, in all over the room. If I can smell it, the anything like if I smoke a tire end of my building, we can smell the starting of the gate. So this is due to the diffusion, and most of the phenomena are the combination of advection plus diffusion. That's why in the momentum equation or heuristic equation there are two terms, most important terms. One is advection term and one is diffusion term. Uh, so which is called as transportation term, which is transport of anything. Uh, so yeah, this is the linear and non-linear, both the terms are there. Diffusion is non-linear. So if you want to solve it numerically, the finite volume method problem, or so I have covered finite difference in the MATLAB section today. Now I want to explain something about finite volume method. So first 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 point is doing or meshing, and before that there are more points we need to define. So do anybody know about it? There is some question. Do anybody know about this meshing? Yeah, tell. So why we are meshing? Okay, okay. Others? We are meshing it because we can't solve the equation in the whole domain, and our equations basically are not partial differential equation. Partial differential equations are defined for a very small domain or control volume, and when when we when we convert it to the algebraic equation, then that equation is can be if we solve it for a larger, you can say larger domain, then it will give us the wrong result, because the approximation, first approximation, as I explained about the h. So this this basically is h. Just think about that that polynomial we solved today. In that, if we reduce the h, then our solution increased, or our solution accuracy of solution is increased. As we reduce h from 0.1 to 0.01, the error reduced from 30% to 0.3%, 0.03%, sorry. So this is why, like, we need to discretize our domain, and for that we need to solve that equation for every particular section. That is why we are meshing. Okay. So first thing is meshing. Another is like we need to define which type of governing equation we need for that particular problem. Okay. uh, And as I said that it is defined for infinitesimal control volume, we need to integrate for every box. For every box we need to integrate it. So there are different integration methods, as you will understand it in the later way, in the later classes. I think it is covered also. So and so we are not solving it in a copy pen. So while integrating, we need to convert it into a algebraic equation, then divide the domain into the finite volume, and yeah, we are solving the equation within that control volume. Okay. Okay. So let's take an example. Let's take an example in which a rod is there for 1D steady state conduction equation. So this rod, suppose this is 1D rod, and we are solving the conduction equation here in this rod. So we meshed it up into the three parts, okay, and then we apply the partial differential equation. So this is the partial differential equation. Here it is like this: dou over t, dou over dou x, and to k dt over dx. It's a Fourier law basically, with source term. So it's called a 1D heat conduction equation, and we need to integrate it for every section. Okay. So it's the part where diffusion only is occurring, not any advection term is occurring. So in this term, in transport equation, I explained that there are two terms. One is advection, one is diffusion. So if I am transferring, if I am heating it from here without any air or anything, so from here it will transfer the temperature to the whole rod by diffusion. There will be no advection in this term. That's why I said that there is no advection in this, and just diffusion is a part of this. So conduction heat transfer is just diffusion basically. So it will make our problem more simpler. So steady state, yeah, it's there. And now let's integrate. How we will integrate is, so let's define it as okay, let's write present. So this is the present point, and this is the eastern point. So in this we are defining east, west, north, south, as we defined in our map. And so this will be east, this will be west, and this will be the present one, whatever I am right now tackling now. So when I am moving from west to east, okay, then I will integrate from west to east. So that's why I have integrated from west to east. And yeah, okay, let me, yeah. So this is the western point, eastern point, and this junction is small w and small e. Okay. So I am solving for this control volume where I want to know the value of temperature. Okay. So from this western junction to eastern junction I will integrate for that equation. That is what I have done here. From western junction to eastern junction I have integrated, western to eastern junction I have integrated, and what it will give is k dt over dx at east point, k dt over dx at west point, plus s delta x. So delta x is the difference between this, means the grid spacing is delta x. Yeah, because from delta x from west to east is delta x. Okay, I hope everybody is getting this, because this is very important. For the next session of MATLAB, this is very important. Am I going a bit fast? Understood? Okay. So so that you understood that why I am integrated in. So in this, again I am explaining. In this pen, I have this section. So this section I want to know from here to here, because I have divided into some section. I want to know the temperature here in the center. So what I will do is integrate from here to here, this point to this point. I will integrate it, and I will know that what's happening inside this, and this will give me the temperature of the center. Okay. Okay, so what we are saying, that equation 1 is not algebraic equation. So how will we convert that into the algebraic equation? Is so what? So let's write it. So the equation is this: k. Okay, let me write by red pen. K dt over dx at eastern point. So eastern point is this. Okay. I don't know what is k dt over dx at eastern point, because it's not an algebraic equation. I need to convert it. So let's see that k is the value of heat transfer coefficient at eastern point. Let's assume anything. And dt over dx is what? dt over dx is the slope of the temperature from this point to this point. Okay, so let's assume it's linear temperature difference between P to capital E, capital P to capital E, linear temperature difference. It's an assumption, first assumption which we are taking. So what will happen is, this will show the value of temperature at E minus value of temperature at P by the difference between these two is delta XE. Suppose we are calling it delta XE. So delta XE. So similar way I am removing this. I have written already here. So this is converted here, and this is the profile choice which I have considered as linear. So this is the first choice I have taken, and let's see how far I can go. So similar way, TP minus TW by delta XE, delta XW will be there. So delta XW plus S into delta X, and now I think we have converted that into the algebraic equation. Let's separate TP terms. TP means the temperature present which we need to find out, present temperature which we need to find out. So TP is segregated, TP is segregated, and these two terms are here. TW is there. Let's call this as AP, means the present coefficient of the temperature. Present, so AE is here, and we are calling it as AW. So this is the one of the algebraic equation. So I have an algebraic equation right now. So this algebraic equation can be solved in our system, which I will explain by Thomas algorithm, or any algorithm we can solve. So Thomas algorithm is one of the way to solve this kind of algebraic equations. Okay, let's come where convection and diffusion both are coming. But before that, I need to ask you. Okay, it's a very I need to ask you in this any problem. Okay. Because it's a very important concept. Guys need to understand. No problem. Later you guys will face some problem writing codes. So these are the basics for that writing code. That is nothing but equations in the form of why advection, not because there is no advection, Sanatha. There is no advection term here. Okay. So you see here in the conduction, any air is not moving. If you solve any air conduction problem, so there is nothing, no movement of air, no movement of fluid. That's why there is no advection. Advection comes only because of when something moves, it takes away something, then advection comes. So in conduction there is no, in pure conduction problem, there is no movement of any fluid. No, not heat exchange. Heat exchange can be between fluid and solid by conduction. Heat exchange means, suppose I am blowing, this is a heated pencil. If I blow this, what will happen? This will take away the heat. Okay, but this is advection. But if I heat this rod from here, and the temperature will of all the pencil is rising, so it is due to conduction only. I have not done anything. I just heat it from here, and temperature of all the pencil is rising. It's due to diffusion only. Okay, you understood. Yeah, kind of. Okay. I wanted to cover today 1D diffusion equation method. Do you guys need some break of 5 minutes? This is cover profile choice everything. So in convection and diffusion, both the let's consider both convection and diffusion. Okay. So this is the journal form. Okay, journal form, and this is the our advection term, and this is our diffusion term. This only contributes toward the convection. Okay. Sorry. So let's consider this. And phi is anything can be phi. Phi can be temperature, phi can be velocity. Okay. So let's write down in a 1D form in a differential manner. So this, if you like expand this, it will come out as d over dx OU. So this is v, but in the one dimension it will be u, and d over dx and gamma del over del x of phi. Okay, so this I have just converted into the differential form. So let's do the finite volume method and thus in in which we are integrated from west to east, similar way which I explained here. In this we are from west to east. I need to sorry, this from western to eastern phase or junction. I need to do integration. So here also I am doing that kind of integration from western to eastern point. Okay. How will you do? Is rho u phi E at eastern point, rho u phi at W. So this is the advection term which is coming here, and this is similar terms as we have done in the conduction part. It's the diffusion. So from east to west. Okay. So here I think this is clear, but yeah, how will you see? How will you calculate at phi? So phi at E will be phi at P. Again, I am taking the average of P plus E by 2, and here also I will take the phi P plus phi W by 2, phi W. So these two approximation I will apply here. So these are the first approximation. Later I will tell you other approximations, such as in which I think not linear, not average are considered. But these are the first type of approximations, and similarly we will come down to the similar equation, and we can solve. So now I think we have gone through how to generate the algebraic equation. How to solve that algebraic equation is another game. So yeah, I think you are learning in the classes, but maybe I'll tell some basics about that in the next class. So equations, so I am just recapping it. First we need to have some equations. So system to control volume, we need to convert it. Yeah, we need to discretize or make grid of the domain, and for meshing, and then integrating it, then converting that into the algebraic equation in this form, and then solving the system of equations. System of equation means this you got for one grid. Okay, for this grid you got. Next time this will be the present grid, this will be the western grid, this another will be the boundary condition. Then you will get for this another equation, you will get similar AP, EP, something like you will get another. For every grid point you will get it. Then it is called as system of equation. Means number of equations will be there with you. You need to solve by making a matrix. So yeah, that's the part. That's called system of equation, for which we need to understand different equations solving method or matrix solving method. Okay. Okay. In this, any problem? I'm thinking that others are not getting. Yeah, you understood, but others, like there are very less people still, they are not responding. Preeti, clear? So now you can solve some problems of assignment directly given. Let me check about the assignment 4. And I asked you what assignment 4. I am checking it. So you said that we need Thomas algorithm for them. Let me see why we need Thomas algorithm. This is the assignment. I don't think that we need. Yeah, yeah, yeah. I understood. I understood. I got the problem. What you are saying, please say again. Hmm. Yeah, 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 yeah. So, mm-hmm. So what's the problem you are facing? Mhm. At least what you can do is, right today I told you about creating the system of equations. So at least you can create that system of equation. So what you will do is, like, suppose a x plus b plus c x square plus b equal to 0. Here we have this equation. Another equation is similar. So d x square plus uh, yx plus uh, so, dx plus f is equal to 0. So you make this type of equations, and you just segregate all the terms here. Okay. So this x square x um, 1 and other a b c d e f 0 something you arrange, and then make this system of equation. Then suppose if you have this, then you can directly do it in MATLAB. Okay, first thing. And next is that sweeping method of Thomas algorithm will come into the picture. Yeah, I will do it. Like, I have done it already in one of my previous sessions. Not this year, last year. So exactly, sweep method. Sweep method is that Thomas algorithm, I think. No, no, no. You can go for larger also. But here, idea of giving the assignment is to use Thomas algorithm, I think. So, yeah, you can do it via both methods, but I am not very sure. You try, make a system of equation first, then you will get ideas. I think tomorrow you will get the lectures. So about Thomas algorithm, I will explain. Basic problem, I think I will upload that lecture. Means the previous lecture I haven't uploaded. In that, for 1 hour I have already that lecture. For 1 hour I will upload for Thomas algorithm. Yeah, yeah, yes, Sanatha, you are correct. It should be, it will be around that. Yeah, as far as I remember. So 10 by 10 grid. Yeah, you need to sweep it, like solve one equation, replace that, then sweep it, that's the same line, then again. So it's a repetition, iterative process. That also you can do it in MATLAB. uh, by defining loops. But yeah, I will explain that. Okay, I think let's end it today. Yeah, I will tell. So for week three's lecture, I haven't uploaded lecture on YouTube. So when I will upload for 1 hour whatever I have taken last week, and after 1 hour I left because of my health reason. So that for 1 hour I will explain about Thomas algorithm by today or tomorrow. I will by tomorrow or day after tomorrow. Till then I will upload that. Okay. I think we can now. Uh, like we can wrap this session up, and let's meet after some time after next week. So next week, do you want me to cover anything? Tell me. Do you like the MATLAB session? So I will continue with MATLAB only. That will be more useful. Sure. So I will. Okay. Yeah, it's not for CFD. Okay. Bye. Take care.